computers destroy your life. Careful of the games they play with the modern technology. Oh, let me tell you, in this new age, Babylon culture, don't worship technology and bow to computers. Cause the microchip is gone, chip and failure, and bring you straight forward to creation. In this new age, Babylon culture, don't worship technology and bow to computers. Cause the microchip is gone, chip and failure, and bring you straight forward to creation. And now we're slowly depending on the machinery. Man, make the machine and get trapped in the air. Slowly depending on the technology. Caught in the web and can't come out of it. In a 1999, and I did that fret and worry. Wonder if the clock did that go stop in the air. Counting down the time.
In today's class, we'll be looking at the processing cycle.
Excellent.
Okay. The processing of data to get information involves three basic stages. Okay. These basic stages are input, processing, and output. And I put a little diagram here so you can see it. Input, processing, and output. Now, I might just give you this diagram, leave out one, and you might have to write in the one that is missing. And of course, remember it said that this is the basic stage of the processing. So therefore, bear in mind that we have more complicated examples. This is just a simple way of getting you to envision it in your mind. Okay. Central or key to this processing is the central processing unit. Most people call it the CPU. Okay. This is what the CPU looks like, please. This is what the CPU looks like. These are the newer types. They're new because they don't carry the pins, like the next set I'm about to show you. Okay. Here is the older type CPU where it carries the pins, where you have to push it in the motherboard and it used to have to fit exactly into the hole. And if it doesn't fit, then it will not work on the motherboard. Sometimes you try to push it in there and force it, and it will actually bend the pins and damage it. And these things are very expensive, so you lose your money if you damage it. Nowadays though, they use this type where there's no pins, it's just contact to contact, and there's less likelihood of damage. Alright, so the CPU is the brain of the computer. So just like how you have a brain, the computer has a brain. It takes raw data and turns it into information. Please refer to your input-output devices notes if you don't remember about converting data to information. Okay. The central processing unit, or CPU, notice I put it in red to indicate that it is an abbreviation or an acronym. In this case, it's an abbreviation. It doesn't spell a word. So the CPU, or the central processing unit, is made up of two smaller units. These are the control unit, aka the CU, and the arithmetic and logic unit, ALU. The control unit, let's deal with that one first, is the main part of the CPU. Input is first sent to the CU, from where it is then sent to the allocated part of the computer to be processed. The CU decides where to send data to be processed. After processing, the information is returned to the control unit. Okay, so basically what's happening is that the CU is sending data and instructions to the ALU. The ALU in turns calculates and works out what should be done, where it should be done, and so on and so forth. The ALU, let's go in more detail now. The ALU, or the arithmetic logic unit, performs all the arithmetic and logic functions in a computer, Please bear in mind, computers don't speak words or letters. They only know numbers, and the only two numbers they know are ones and zeros, which is called what? Binary.
It's a common theme throughout the modern world that everything in a computer's brain comes down to ones and zeros. You've most likely heard that this code of ones and zeros is what's referred to as binary.
For example, if an instruction involves an arithmetic operation such as addition, subtraction, multiplication, or division, or the comparison of the data, the CU sends the data to the ALU for processing. Some of the logic functions are comparisons, such as we have equal to, that's the equal to symbol right there, less than, less than symbol right there, greater than, that's the greater than symbol right there, less than or equal to, this is the less than or equal to symbol, and then we have greater than or equal to symbol, and then we have not equal to symbol. Alright, so these are the functions that the ALU will use. These are the operators that the ALU will use to carry out its function. So if it's going to compare something, you can compare whether this is less than that, or if this is greater than that, or if this is equal to that, and then based on the calculation, it does the required operation. The main memory. Alright. The main memory, also known as RAM, RAM, this is an example of RAM, which is directly accessible to the CPU, holds data and instructions that the computer is processing at the time. Therefore, the data collected in the previous example about students' heights would have to be placed in main memory while it is being processed. Alright, so let's say that the raw data is students' height. That was the example given. The students' heights. When you enter the students' heights, you can then process the data by putting them in ascending order. Ascending means going up from smallest to largest, or you could put in descending order from largest to smallest. That's all that means. Alright, output devices now. Output devices translate information processed by the computer into a form which the user can understand. So after the CPU carries out its operation, the CU sends it to the ALU sends it back to the CU then returns the results either to main memory, which is a primary storage, or RAM, and then or it can send it to another output device such as the monitor, which is a screen you might call it. It can be a thumb drive you can send it to, or it can even be speakers you can send it to, which is a form of output device. So after processing, the data and the information can be either stored in a secondary storage device such as a disk, which could be a DVD or a CD, or sent to an output device, or both. So you can send the results of your calculation of the students' heights in order, ascending or descending order, to a thumb drive. You can see it on the screen, or you can even convert it to audio. Alright, so what we're looking at here now is the machine cycle. Every time you put in an instruction, every time you enter some form of data, the computer goes through this cycle. It's a more complicated one to the one above where you had input, processing, and output. It's still saying the same thing. This is just a more detailed breakdown. So first we have the input, and it goes in and it bounces between the CLU and the ALU and main memory. It bounces between the three of them basically, and then once the results are calculated, it sends it to the secondary storage, or it sends it to the output device, whether that is the same thumb drive or the speaker or the monitor. The secondary storage device could also be the hard drive in the computer, or it can be an enclosure or something like that. Alright, so the CPU now, this is the cycle that it goes through. Every time you put in a instruction or you put in data, the first thing it does is it fetches the instructions, open this file, it decodes the instructions, which file it's supposed to open, where it's supposed to save it, it interprets it, interprets the instruction as in this is this type of file, it should be opened by this program, then it executes it by opening the program, then it stores the instruction or the result, which is to put it to the screen or save it to the required secondary storage. Alright, so I came up with the acronym FDIES or Father Dies to help you remember it. You don't have to use this, you can make up your own. This is just my foolishness. This is how I remember it. Fetches the instruction, decodes the instruction, interprets the instruction, executes the instruction, stores the result. So it doesn't have to be instruction. I just type it that way. So it can be fetches the data, decodes the data, interprets the data, executes the operation on the data, stores the result, which would be the information. Right? So that's one way of looking at it. So it doesn't necessarily have to be instruction. It can also be data. And remember, the computer is constantly doing this. It's constantly cycling. Even right now when I'm moving the mouse like this, it is doing this very same process. The instruction is being given, move the mouse X amount of spaces to the right, X amount of spaces down, X amount of spaces to the left, then back up again. And it's doing what? Between the ALU and the CU, it's cycling crunching the numbers, and it's sending the result to the output, which is what? The screen, in this case, the monitor.
Hello, in this video, we are going to understand how computers work. We have already learned that computer is an electronic device which processes instructions given by us. For example, you use your mouse to draw or use your keyboard to write mails on the computer. You can then ask your computer to print the amazing drawing you made on the computer or command it to send the email to your friend. So the computer takes in some input, does some processing on it, and then gives some output. This is called as IPO cycle or input process output cycle. Let's understand each of them. First is input. It is responsible for providing some information or instruction to the computer. It can be through mouse, keyboard, or even voice command through your speaker. Input is a combination of data and instruction. For example, you've given some numbers and ask the computer to do some mathematical calculations on it. Big banks, schools, business give even large amount of data to computers for processing, like processing exam results, money transfer, etc. All of these are input to the computer. Once computer receives the input, it does the processing on it. This is the responsibility of CPU or Central Processing Unit to do the work as per your instructions. A CPU has three main components. First is ALU or Arithmetic and Logical Unit, which is responsible to carry out arithmetic and logical instructions. Second is CU or Control Unit, which controls the sequence of instructions given by us. Third are some registers of fast memory where ALU stores its values while doing its calculation. CPU also works with main memory, also called as RAM or random access memory, which temporarily stores your instructions and data while processing. Once the processing is done, the computer gives the output, which could be displayed on your screen or monitor, or it could be printed on paper or as music on your speaker. Thus the computer follows this whole cycle of taking in input, processing it, and giving the output, which is called as IPO cycle.
Alright. The machine cycle describes what the CPU does. In one machine cycle, the CPU takes a single instruction from the main memory. This is the main memory. Here are some main memories over here. I remember there are different sizes. All right, so it does what? It takes in one machine cycle, the CPU takes a single instruction from main memory and carries it out and carries it out. The CPU does this a million times a second or more, so it's moving very very fast. That's why computers need AC, or that's why they need fans inside of them to help keep them cool, because once they heat up, it damages the CPU. It's the same thing with your brain. If your brain heats up, like you have a fever, and you heat up too much, it can damage your brain. That is why mommy and daddy take a sponge and sponge you down, or them take you and put you in the bath with water, or them turn on the fan pan you for cool you down, you understand? Because they don't want your head to get lick. Just like how the CPU can get lick. Remember, everything in the processor is stored as an electronic number. Instructions are stored as code numbers. So the CPU needs to decode the number to find out what instruction to follow. So remember what I said? The computer only knows ones and zeros. So therefore, it speaks in ones and zeros. And that language is called binary. binary.
Before we get to computers, let's talk about what binary itself is, as it existed long before computers did. Binary is nothing more than a system of counting. To understand how it works, let's look at two other systems of counting, tally marks and the glorious base 10 positional that we all know and love today. Tally marks are the simplest counting system imaginable. However many things you have, you put down that many marks, easy as pie, but not very efficient. Meanwhile, base 10 positional, which is what we use today, uses a different symbol to represent different amounts of things. With the numbers 0 through 9, we can recognize that each symbol indicates a different amount of things. If we need to represent something higher than 9, we add a digit to the left, roll this first digit back to 0, and start over. This system is very efficient compared to tally marks because each digit we add exponentially increases the amount of things we can represent. Because in this system we add a new digit every 10 things, each digit represents an increasing power of 10. This is the number of ones we have, the number of tens, the number of hundreds, the number of thousands, and so on. Now this is probably something you already know, but it's very important to keep it in mind when we talk about binary. Now binary works the exact same way as base 10 positional, but instead of each digit going from 0 to 9, it goes from 0 to 1. Counting upwards in binary sounds like this: 0, 1, 10, 11, 100, 101, 110, 111, and 1000. Because each digit of binary has only 2 values and not 10, each additional digit represents an increasing power of 2 rather than an increasing power of 10. So this is the number of ones we have, the number of 2s, 4s, 8s, 16s, 32s, 64s, 128s, and so on. Not nearly as efficient as base 10, but exponentially more efficient than tally marks. Literally. So now that we know how binary works, let's talk about computers.
The machine cycle is also called the fetch execute cycle. That sounds like a good test question. Or the instruction cycle. And other similar names. Execute means to carry out an instructions. That's what execute means. So if on the test I ask you what does execute mean, you should be able to tell me to carry out an instruction. Alright, let's go into some details now. The CPU decodes the number, same thing like before. The CPU might also need to take some data from main memory. The CPU sends the instruction to the ALU, which is the arithmetic logic unit, to be executed. Any results are copied back to storage and the cycle begins again. Alright, just to point out something here, the main memory is what they call volatile, which means that once power is cut from main memory, everything in there is gone. So when you reach SBA level and you're typing your SBAs, please remember to click the save button. Let me even show you the save button. Here's the save button. See, it even says save, Control S. Please click that save button constantly as you type, click it. As you type, click it. or if you know how to use the keyboard based on the keyboard tutorial that I gave you, you should be able to press Ctrl S and save. Because bad mind JPS, you're there typing your assignment and like go away, you might lose it.
Fight!
Now some programs autosave, I might save a part of it, but why take the chance? Constantly click the save button, please. A lot of students forward complaining that them lose MSB and them want help, and you know, so I'm advising you please to love up the save button.
Outstanding.
Okay. So any results are copied back to storage and the cycle begins again. Different processors work at different speeds, which makes sense because not every animal runs the same. All people don't run at the same speed. In general, processors have become faster over the years. A fast processor can work with a lot of data and process it very quickly. Video clips, for example, are made up of a lot of data. If a computer is used to process video, then it will need a fast processor. So computers that need to work in real time, such as a computer that controls a real machine or helps to fly an airplane, there is no time for delays. Real time means that it responds quickly. That's all real time means. It doesn't hesitate. Within a half a second, nanosecond, it processes and produces the result. Because you need to know where the planes are, how high they are, how fast they're flying, how much gas they have, how much cargo, how much people, the weight they're carrying. This way the computers can calculate which plane to land first, because the heavier plane will burn gas faster and the smaller plane can wait. So they will land the one that has less fuel and so on and so forth, and in that order, just to allow a smooth transition. Okay, measuring speed, and this is the speed of the processor. The speed of the processor can be measured in what's called hertz, and the abbreviation for hertz is Hz. Just like cm is for centimeter or mm is a millimeter, well Hz mean hertz. So this tells you how many cycles there are per second. So how much data the CPU or the computer can process is measured in hertz. Because computers are so fast, processor speeds are measured in megahertz, millions of cycles. So just to show you a little prefix here, mega means million. So you've heard of the Mega Lotto? Everybody want to win Mega Lotto, right? And mega means million. Okay. In IT though, we have what's called giga, and giga deals with billions. Alright, so gigahertz would be faster than megahertz, because mega is million and giga is billion. Which one is bigger, million or billion? If somebody forward tomorrow and say, here is $1 billion and $1 million, which one would you choose? Most people are glad for the million. That's all them know. But anyway, because Mr. Harris teach you, you know that billions is bigger and better than millions when it comes to money anyway. Alright. Bits. What are bits? All of the data in the computer is digital. It is made up of numbers. We said that 2 times already. All the numbers are electronic. They are made from on-off electrical signals, dealing with that same ones and zeros thing. When we write down the numbers, we write 1 when the electrical signal is on, 0 when the electrical signal is off. So all the numbers in the CPU are stored using only ones and zeros. These are called, and I've said it twice already, binary numbers. So all the computer understands is ones and zeros. Bits again. You have seen that the electronic signals in the computer can be in two stages, which is we represent as 1 and 0. Each 1 or 0 is called a bit. So the smallest unit basically is the bit, even though it goes a byte later on, but still. So 1s and 0s represents a bit. This is the smallest piece of information in the computer. So if I ask you on the test, what is the smallest unit of measure in the computer?
Test your
In
might.
terms of data transfer, you should be able to tell me the bit. Alright, what's bigger than the bit now is the byte. What is a byte? A group of 8 bits are called a byte. Please notice, for those of you who are thinking about food, it's spelled B-Y-T-E, and therefore it's a different type of byte. So, how many bits make a byte? It said 8. Let's emphasize that. 8 bits make 1 byte. That's a good test question, you know. A byte is about enough computer memory to store 1 letter or 1 digit. So a byte is enough storage to store what? 1 letter or 1 digit. A byte is the basic unit of computer memory. So the byte is the basic unit of what? Computer memory. Computer storage is measured in bytes. Kilo is a Greek word, means 1,000. So a kilogram is 1,000 grams. A kilometer is 1,000 meters. A kilobyte is approximately 1,024 bytes. Approximately. A mega, there's that mega word again. A megabyte is approximately what? 1,000 bytes. A gigabyte is approximately 1,000 megabytes. Please make sure you read through these in detail and know them. A tera, which is the biggest one now, a terabyte is approximately 1 trillion bytes or 1,000 bytes. I wouldn't say it's the biggest one anymore because they've gone up to quads now. What's bigger than a terabyte is a quad, but it's mostly military and those huge processing like NSA and National Security Agency and those big companies would use those quads. They wouldn't be available to regular people unless you have the billions and the billions we were talking about to buy them. But terabyte is the biggest right now that we have access to, and it's very decent. It's very decent size. It can hold a lot of movies. It can hold all of your music them where you have, plus 10 more people one, and it can hold a lot of movies. Trust me. All right, what is a word? All right, no, this is not the word where you tell somebody when you get vexed. In computing, a word is the number of bits that can be processed in one action by the machine. Typically, a computer with a large word can work more quickly, though this is not always the case. So think of the word as how much processing it can do. Features of the CPU such as registers, the bus, and the actions of the fetch execute cycle are linked to the size of the word. So when you're buying CPUs, generally we look at the speed of them, which is measured in hertz. So a 4 gigahertz CPU would be better than a 2 gigahertz CPU, especially if you're doing video applications like what I'm doing now. You need a very fast processing processor. Modern computers usually have a word size of 16, 32, or 64 bits. Data is stored in the processor as numbers that are made up of electronic signals represented by ones and zeros. Okay, we don't use 16 bits motherboards or computers anymore. That's old technology. Nowadays we only use 32 and 64. And as a matter of fact, they're phasing out 32. They're phasing out the 32 and now they have gone 64 to 86 bits. Of course, the 86 bits will be more expensive, so if you're lucky enough, you'd probably have to go to Kingston and buy a 86-bit motherboard. But 64 bits are still common, and you can get them readily. You can also set the operating system to run at 32 bits or 64 bits or 86 bits, whichever one suits your needs. Okay, so that basically concludes for the processing cycle. If you're not sure of anything, please watch it again. It will be available for you until the test. After the test, I'm going to take it down, put up something else because I need space. I don't have a lot of space. And what you can do is download it to your phone so you can watch it over and over again. Or if you have a laptop, download it to your laptop so you can watch it over and over again.
Well done. Impressive.
I'm thankful you, Jah gon' bless us and make us strong. I trust that we'll be there someday to come. I never doubted, I keep the faith all along. A good friend, I'm a servant, that's who I am. You surely deserve all the best there is. And I've got all the love